Hello friends of EduMath, this is Gerard Makumba. In this video, we are going to look at motion under gravity. And if you are new here at EduMath, consider subscribing and hitting the notification bell such that you are notified whenever we upload a video. For now, let's get started. So under here, the equations of motion can be modified when dealing with a body that is moving freely under gravity. Now we shall have like 3 ways under which a body can freely move under gravity. Number 1, when the body is projected at a certain angle. That's projectile motion, we shall see that. Secondly, this body can be projected vertically upwards. Okay, that's the second case. The third case is when the body is projected vertically downwards. So in this video, we are going to combine the two, where the body is projected upwards and where the body is projected downwards. So the equations of motion, we can recap them here, but we derived them, and I'm going to link the video here in the cards. You can check on it. Equations of motion, we had that V, the velocity, is equal to U plus AT. The displacement is equal to UT plus half AT squared. We had V squared being equal to U squared plus 2AS, where V is the final velocity. Then we've got U, which is the initial velocity, and that S is the displacement, then A is the acceleration, and under here, where the body will be moving freely under gravity, the acceleration will be the acceleration due to gravity, G. Okay, then T is the time taken. Alright, like now we said, we are going to consider 2 cases when the body has been vertically projected upwards and when the body has been vertically projected downwards. Now, for a body projected vertically downwards, the value of the acceleration A is going to be positive G. We say that here acceleration will be G. So here the value of the acceleration will be positive G because it is in the direction of the acceleration due to gravity. So therefore, the equations of motion here will be modified as the first one will be V being equal to U plus GT. The second one will be displacement being equal to UT plus half GT squared. The third one will be V squared being equal to U squared plus 2GS. Okay. Now these are the 3 modified equations when the body is projected vertically downwards. Now for a body projected vertically upwards, the acceleration is going to be negative G because this body is moving against gravity. So therefore our equations are going to be modified as V being equal to U plus negative GT, which reduces to V being equal to U minus GT. The second equation here will be modified as displacement being equal to UT minus a half GT squared. The minus is coming in because we have acceleration being negative G. And the third one is V squared being equal to U squared minus 2G times the displacement, the negative also coming in as a result of a negative acceleration. Alright, now we've reached the point of using these equations in guiding examples. In our first guiding example, they are saying that a stone is thrown vertically upwards with a speed of 20 meters per second. So the initial speed U is going to be equal to 20 meters per second and it is projected upwards. You know, when you are on Earth, whatever goes up must come down. So why does it come down? It comes down because the acceleration is negative G. Okay, meaning that this velocity will go on reducing up to when a certain point is reached. That point is the highest point the body can go. So when that point is reached, the velocity at that point is 0. Okay, so that's when this body now moves freely under gravity. It's pulled downwards. Now this stone was vertically projected upwards with a speed of 20 meters per second from a point h meters above the level ground, and after time t, which is 5 seconds, this stone lands on the ground. T here is equal to 5 seconds. First, in mechanics here, a sketch is very important. So we are going to have here a sketch, which is the interpretation of this question here. So this here is our height h, and this here is going to be the point where this stone is thrown from. So it's going to be thrown from that point, goes up, turns, and comes back to fall on the leveled ground. Okay, now first we know that if this stone has to move from here and comes up to this point here, same level, it has moved 0 displacement. Now when it is moving up here, it is moving with an initial velocity of 20 meters per second upward. Now when it reaches this side and turns and moves down, it means that we shall have a negative displacement. That's why we have that from here to here it is 0 displacement. These journeys cancel themselves here. Okay, so at the turning point here, the final velocity is 0 meters per second. So when it turns, reaches this point here, remember the distances traveled are the same, and if they are in opposite directions, they will cancel themselves. Okay, so going down means a negative journey. So from here we conclude that okay, the displacement there is negative h. Alright, so we need to find the h. So using the displacement is equal to ut plus a half at squared. Okay, so we can now substitute in. We have displacement is now negative h being equal to u, which is 20 times our t, which is 5, plus, now moving upwards, that's negative g. This is a half times negative g times we have t squared, and our t is 5. Okay, the value of g is 9.8 here in mechanics of mathematics. So this negative h being equal to 100 minus half times 9.8 times 25. So when we work on this here, negative h is equal to 100 minus 122.5. So h is going to be equal to 22.5 meters. So that is the value of h for this question here. Our second example says a ball is thrown vertically upwards from level ground with velocity 28 meters per second. So if it is vertically upwards, first of all, our acceleration is negative g. Okay, then the initial velocity is 28 meters per second. It is upwards. Now they need us to find the maximum height above the ground. So we can sketch this as well and see what we come up with. We projected from here, turned, came back here. They need us to find the maximum height. We can call it h. So how do we find h? We know that at maximum point, the final velocity there is equal to 0 meters per second, right? So we can now use v squared being equal to u squared plus 2as at maximum height. V is equal to 0 meters per second. So therefore we are going to substitute in here. We shall have 0 squared being equal to u is 28 power 2 plus 2 times our a, but a is equal to negative g, which is equal to negative 9.8 times the distance it travels to reach the maximum height, which is small h, right? So this is 0 being equal to 784 minus 19.6 h. This implies that 19.6 h is equal to 784, and h alone is equal to 784 divided by 19.6. h is equal to 40 meters. That's part A. Now part B is asking us to find how long did it take to return to the ground. Now if this ball has to move from the ground, comes back to the ground, it means that the displacement traveled there is 0 meters. Okay? Yes, the point of origin is the ground and the final point is still the ground. So therefore, the displacement is 0 meters. So we are going to use the second equation, using the displacement is equal to ut plus a half at squared. So if this ball has to move from the ground and comes back to the ground, displacement is 0, being equal to u, the initial velocity is 28 meters per second, times the t which we need to find. This ball is moving upwards against gravity, meaning the acceleration is negative g. So this is a half times 9.8 t squared. This is the same as 0 being equal to 28t minus 4.9 t squared. We can factorize out a t here, so that we have t into bracket 28 minus 4.9 t being equal to 0. So either t is equal to 0 or this bracket here is equal to 0. Solving this quadratic here, 28 minus 4.9 t equal to 0. So from here, t is equal to 28 divided by 4.9, and t is equal to 5.71 seconds. Okay, so at the point of projection, that t is equal to 0. So when it moves from here to here, t is going to be 5.71 seconds. Our number 3 is here. A brick is vertically thrown downwards from the top of the building and has an initial velocity 1.5 meters per second. So here we have u is 1.5 meters per second. It's moving downwards. Okay, so the acceleration this time around, it is positive g. They have given us that the height of the building is 19 whole number 2 all over 7 meters. Now required here is to calculate the velocity with which the brick hits the ground. So we need to find the final velocity that. Now this h here is the displacement of the brick from the original position, which is the top of the building. So using v squared being equal to u squared plus 2as here, we now need v. This is v squared being equal to our u is 1.5 squared plus, because it is being projected downwards, 2 times 9.8 times the displacement is 19 whole number 12 all over 7. So we get v squared being equal to 2.25 plus 19.6 times, let's convert this to improper fraction, which is 135 all over 7. So on simplifying this, v squared is equal to 380.25. But we need v, so we have got to take the square root on both sides. So v is going to be equal to the square root of 380.25. v is equal to 19.5 meters per second. So this is the velocity with which the brick hits the ground. Part B. They need us to find the time taken for the brick to fall and hit the ground. First, we know the initial acceleration u, 1.5 meters per second. It's moving down. We know the final velocity now. We've calculated it as 19.5 meters per second. We know the acceleration. This brick is moving vertically downwards. Acceleration is equal to positive g. And they need us to find the time. So using the first equation, v is equal to u plus at. So we substitute in there. We shall have 19.5 being equal to 1.5 plus 9.8 standing in for a, and that's the acceleration due to gravity, t. So when 1.5 crosses, we have 18 being equal to 9.8. So t here is equal to 1.84 seconds. So this is the time within which the brick is able to move from the top of the building to hit the ground. Our fourth example is here. A ball is thrown vertically upwards with a velocity of 14.7 meters per second. Initial velocity 14.7 meters per second from a platform. So we have a platform where we are throwing it from 19.6 meters above the level ground. So we need to have a sketch. This is our level ground, and this here is the platform, which is 19.6 meters. So this ball is vertically thrown upwards, then it reaches the maximum height, comes back to the ground. It is projected up with an initial velocity of 14.7. Now, we already know that acceleration is going to be negative g because we are moving against the gravity. The normal direction of projection is upward, so the distance going up is going to become positive. So when it reaches the maximum point here, it will come back downwards. That distance is going to be treated as negative. So the whole of this moving down is going to be a negative distance. Why are we doing that? To find the displacement. So the displacement from this point of projection up to where it hits the ground is going to be negative 19.6 meters. Reason being, from here up to this other point here, the displacement is 0. So we are left with moving this negative journey. Alright, so we need to find the time taken for the ball to reach the ground. T is what we need. So given the data that we have, we are going to use that displacement is equal to ut plus a half at squared. So substituting in, we have negative 19.6 being equal to u, which is 14.7, t, because we need to find the time, minus half times g. G is now going to be 9.8 t squared. So this is forming a quadratic equation. Alright, so on simplifying this, we have negative 19.6 being equal to 14.7t minus 4.9t squared. So the quadratic equation becomes 4.9t squared. I'm bringing these terms this side here, minus 14.7t minus 19.6, giving us a 0. So we need to solve the quadratic. Now, since you are students of advanced level, you will have to solve that quadratic, and you'll end up with t being equal to positive 4 seconds and t is equal to negative 1. Now, we cannot have negative time, so therefore this one is going to be ignored. Okay, so now the time taken for this ball to move from this point of projection to the level ground is 4 seconds. Part B, the velocity of the ball when it hits the ground. We need to find the velocity of the ball when it hits the ground. Now, using that v is equal to u plus at, we need to find the final velocity, the velocity with which it hits the ground. We have u, we have the acceleration, which is acceleration due to gravity. We have the time. So V is equal to our U is 14.7 minus our acceleration 9.8 times the time taken to hit the ground is 4 seconds. So on simplifying this, V is going to be equal to negative 24.5 meters per second. This negative simply means the ball is moving in the opposite direction. So therefore, the final velocity is 24.5 meters per second downward. Now, my dear viewer, I would like to thank you very much for being part of EduMath up to this point. Now, this has been part 1 of motion under gravity. Subscribe if you have not subscribed to receive the notification when we make a video for part 2. For now, from us EduMath, we wish you the best and see you in the next video.